Now for tutorial question 2a, you are given an inequality involving an algebraic fraction again. So what we do this time, as usual, is to first check for which particular values of x is this algebraic fraction undefined at. Okay, so we see in this case, this algebraic fraction is undefined, okay, when x is negative 1/3. Okay, so we shall impose the condition that x cannot be equals to negative 1/3 in this case. Okay, so from here, now what we do is we multiply both sides of the inequality by a suitable positive expression so that we can actually get a inequality involving a polynomial in x. Okay, so in this case, we can see that the denominator, the square of 3x plus 1, is always positive. Okay, as long as x is not negative 1/3, but that is not a problem because we have already excluded it from our possible set of solutions. Okay, so in this case, we just have to multiply both sides of the inequality by the square of 3x plus 1. So what we get now is just 3 minus x multiplied by the fourth power of x plus 5 multiplied by the square of x minus 2 is greater or equals to 0. Okay, so now let us draw the number line. Okay, and indicate the roots as well as the values for which x is undefined at on the number line. So in this case, we have negative 5, negative 1/3, 2, and 3. Okay, so in this case, since the inequality is non-strict, okay, we shall include each of the roots of the polynomial by indicating a black dot on each of the roots, and we exclude negative 1/3 by indicating a hollow circle on the value of x equals to negative 1/3. Okay, so now we can actually sketch the graph. Okay, so we will pick an arbitrary value of x. In this case, again, a good choice would be x equals to 0. So when x equals to 0, the left hand side of the inequality is actually equals to 3 times 5 to the power of 4 times square of negative 2, which is equals to some positive number. Okay, so if we look at the expression at x equals to 0, okay, the point on the graph should lie above the x-axis at this value of x. Okay, so to draw the rest of the graph, okay, we need to first look at the power of each of the factors corresponding to each of the root. So we see that corresponding to the root of x equals to 2, the power of the corresponding factor is 2. Okay, and for negative 5, the root of negative 5, the power of the factor is 4. Okay, whereas for the root of 3, the power on the factor is 1. Okay, so what we should observe is that the graph will actually cut the x-axis naturally at the root of 3, okay, while there should be a turning point on the other two roots at negative 5 and 2. Okay, so we can draw our graph accordingly. Okay, so now since the inequality is for greater or equals to 0, okay, we'll look at the part or the intervals of value of x for which the graph is above the x-axis. So in this case it will be everywhere, okay, from starting from negative infinity all the way until 3, but not including the value at x equals to negative 1/3. Okay, so we could write our answer as x is less or equals to 3 and x cannot be negative 1/3. Okay, or if you prefer to write in another manner, okay, we could write it as x is strictly less than negative 1/3, or negative 1/3 is strictly smaller than x is less or equals to 3. And this will be our final answer for this question.